Okay, in this lesson we are going to see access modifiers of the fields. Access modifiers of the fields. Okay, now in fields we are able to give different access modifiers. What are they? 5 access modifiers we can provide. That is private, protected, internal, public. 5 access modifiers we can provide for the fields. The differences I want to explain now very clearly for you. So try to observe. We have private, protected, internal, protected internal, and public. We have 5 access modifiers available for the fields. Then how these particular things are accessible? Let's try to check. We have 2 things: same assembly other assembly. We have 2 things: same assembly, other assembly. What is exactly meant by assembly here? Compiled source code of the program is called as assembly. You are writing a program, right? That is a C# file, right? The C# file is being compiled into exe file. The exe file contains which language program? MSA language program. That is nothing but assembly. Same assembly means we are presently writing a class. For example, you are writing a student class. The student class is present in one assembly. That assembly we assume as a same assembly or current assembly, present assembly. We have a different assembly. That is what we call it as other assembly. See, just a small example I will provide to understand. Suppose you are living in one country now, right now. In which country you are living now? India. That is our current country, present country. We have different other countries also. All the remaining other countries are what? Other countries, different other countries other than India. Just like that. Presently, right now, we are writing a class in one particular program. That program compiled assembly is nothing but what? Same assembly. You can also think about same program also you can say. Just other programs are called as other assemblies. Same program, other program also you can think of. Okay, now check it. We have same class. Same class. Same class means presently you are pointing to one particular class. For example, you are developing the student class. That student class itself is called as same class. And for the same class, we can create the child class. In object-oriented programming, we have inheritance topic. Based on the parent class, we can create the child class. So, we can create which one? A child class. And also we have other class. Okay. So, this is the same class. For this class, this is the child. Other class means not a child, just a different class. For this class, this one is a child. This is the parent, this one is a child. But this is not a child of this same class. This is just a different class. Okay, now, in the other assembly, that means in a different program, we have child class, other class. So this type of environment we should have, then we can understand the clear-cut meanings of all that access modifiers. Okay, try to check it out. In the same class, private members accessible. Just check it. Private members accessible. Private members accessible within the same class only. The private members of this particular class are accessible within the same class only. Where the private member is created here? In the same class. Where it is accessible? In the same class only. In which class you created the private member? The private member is accessible within the same class only. Here member means maybe a field or method, any other. Fields and methods, all these are what? Members. Okay, so you can also say field. Okay, so private field of this particular class is accessible within the same class only. Can I access that private member here? No. Private member here? No. Private member here? No. The private member belongs to this class, are not accessible everywhere, not accessible anywhere. But you created a protected member. This protected member is accessible in what places? This protected member is accessible in the same class and in all the child classes of the particular class. For this class, this one is a child, this one also child, right? For this class, this is a child, this one also child. Okay, now in this child class, the protected member accessible. Protected member, where it is created? In this class. In its children also it is accessible. This one also child of this class only, right? So here also we are able to access that protected member. The protected member originally created in this class, in the same class anywhere, definitely accessible. In the child class, of the same assembly, in the child class of the other assembly also, the protected member accessible. Okay, next. Now the third one is what? Internal. The internal member is accessible in the same class. The internal member of this class is accessible in the same class. See, by default, all members are accessible in the same class. So there is no doubt about it. But the question about the remaining class only. Okay. The internal member is accessible in the child classes also. The internal member is accessible in the other class of the same assembly also. But this internal member is not accessible anywhere in the other assembly. In other assembly, in the child class or maybe in the other class, nowhere it is accessible. Nowhere it is accessible. Internal means within the same assembly only. But if you go outside the boundaries of the same assembly, it is not accessible. That is what you call it as internal. Next, protected internal. This one is what? Combination of both protected plus internal at a time. That means wherever protected is accessible, there itself this one is accessible. Wherever internal is accessible, there itself this one is accessible. It's a combination of, it's a union of both protected plus internal. See, tell me where this protected is accessible? Here, here and here, right? There itself undoubtedly protected internal accessible. So here we can access that protected internal. Can we access that protected internal here? Yes, because protected is accessible, right? There itself protected internal also accessible. Here which one is not accessible? Internal not accessible here. Internal accessible here, but not in this child class. What is the difference between this child class and that child class? This child class is present inside the same assembly. That child class is present at the other assembly. That is the difference. Okay, now next, public. This public member of this particular class is accessible by default in the same class of codes and accessible everywhere. Everywhere else. Undoubtedly, unconditionally, unrestrictedly, everywhere, globally it is accessible. That is what? Public. So definitely here it is accessible. Public accessible everywhere. Here. Here. And here. Everywhere it is accessible. So this is the complete picture you have to understand. Okay, private is accessible in the same class. Protected accessible in the same class plus child class at the same assembly, child class at other assembly. Internal accessible in the same class, in the child class at the same assembly, other class at the same assembly, but not in other assemblies. Protected internal is a union of both protected plus internal. So protected internal is accessible in the same class, in the child class of the same assembly, other class of the same assembly. Sorry, here protected internal missing actually. Okay, protected internal is accessible in the same class and in the child class of the same assembly, other class of the same assembly. Protected internal is accessible in the child class at the other assembly also, but not accessible in the other class of the other assembly. Public is accessible everywhere. These are all the 5 access modifiers we have understood for fields. Access modifier for the class is different, for the fields is different, for the methods is different, for the constructors is different, for the destructors is different. For each point, different access modifiers. Separately we have to learn, separately we have to remember. For the classes, how many access modifiers? 2 only. Internal, public. Default is internal. Means if you don't specify any access modifier for the class, just you have written class name. For the class itself, which access modifier is applied? Internal. What is the meaning of internal class? That internal class is accessible within the same assembly only, not in other assembly. Public class means accessible in the same assembly plus other assembly also. That is only talking about the classes. Here we talk about the fields. For the fields, these are available. This point we have understood. For methods, for constructors, for others, one by one we will learn later. So this is all about the access modifiers. Now we have to see one demonstration on this access modifier practically. Then we can conclude this particular topic. Okay, now we are going to understand the example on the access modifiers of the fields. Example on access modifiers of the fields. Okay, so to demonstrate this, we require 2 assemblies, right? 2 assemblies means what? 2 programs you have to create. That's why we are going to create file1.cs, file2.cs, 2 programs. Each program must be compiled into exe file. So file1.cs converted into which file now? File1.exe file. Same way file2.cs converted into file2.exe. These exe files are called as assemblies. File1.exe, file2.exe, both are what? Assemblies. Okay, now you are writing a class inside the file1.cs. After compilation, that same class only in MSA language exists in which file? File1.exe file. That's why logically the class exists in file1.exe at the execution point of view. Development point of view, the class exists in file1.cs only. At the time of execution perspective, the class is present in file1.exe. Okay. Now, I want to take that same assembly, other assembly concept. Same assembly means what we assume? File1.exe. Other assembly means file2.exe. Okay, just take this. We are going to create first file1.cs. Next we are going to create which one now? File2.cs. We have created two files, just check it. File1 and file2. Two files exist. Okay, fine. Now in the file1 we are going to create a class called sample. In this sample class we have all types of fields: private, int, a. If you want, you can give some default value. If you want, you can give some default value. It's up to you. This default value initialization is not compulsory. It is just optional. Okay, now protected int b equal to 20. Just for example only I am giving int. We can also give any other data type, whatever you like. Internal, protected internal, public, like this. We have given all access modifiers. By default, all these access modifiers means all the fields are accessible within the same class. Within the same class, undoubtedly, all are accessible. There is no doubt about it. Only the question is about the other classes. Anyways, now I am going to print these particular values in the same class. But how to print? In order to print the value, we require to write the statement system.console.writeLine of that particular variable a something. But the problem is we cannot give this particular statement directly. In the class, direct statements not allowed, only declarations allowed. Then what to do? We can write this statement inside any one method or constructor. So at this moment we have not discussed about the methods, even we have not discussed about constructors also, but at least just to complete this particular example I am going to add the constructor in this particular class. Anyways, I will take constructors exclusive separate session for constructors. So at this moment just let me use the constructor. We are writing public class name now, that is what constructor. Public class name we are writing public space current working class name. Which class you are writing? Sample. So same class name brackets. This part is what? Constructor. Anyways, how to create the constructor? What is the syntax of the constructor? What is the importance of the constructor? All that we'll discuss exclusively later. Okay, in this constructor only we can write this particular statement. So we are just printing all the values, whatever we created, same values. Even this constructor also assumed within the same class only, right? This constructor also part of the same class. That's why we said within the same class all members accessible, private, protected, internal, public, everything accessible in the same class, undoubtedly. But the question is about the other remaining classes. So next we are going for child class. As per the inheritance topic, we can create the parent class and child class. This sample act as a parent class here. Sample 2 we are going to create. Sample 2 is a child of a sample. So sample What is the meaning of this particular notation? We are saying that this particular sample2 is the child of sample class. Now in this one we are able to access the constructor, we are able to create the constructor. So public sample2, public sample was the constructor of the sample class, that is over, the class definition over. In a separate class, public sample2, this is the constructor for this sample2 class. Now the question is, how many members accessible through this particular in this particular constructor of the child class? Answer is, can we access the private member A? Can we access? No. If we try to compile this, we are getting error saying that sample.a is inaccessible due to its production level. The A is not accessible because it's a private member of the particular sample class. Now B, can we access B? Yes. B is what? Protected member. So protected member is accessible in the child class. Next, can we access the internal? Yes. Protected internal? Yes. Public? Yes. Except private, all remaining accessible here. If you want, you can check that previous chart what I have explained previously in the board. Okay, so this part is clear. Next one, I am going to create a sample 3. But what about this sample 3? Sample 3 is just other class. It's not a child of sample. For the other class, which are accessible? Guess. You can also check previously. Private, not accessible. Protected, not accessible. Which others accessible? Internal. Protected, internal, public. That is C, D, E respectively accessible. C, D, E only accessible in the this one. That is respectively internal, protected, internal, public only accessible. Okay, this part is very clear for us. Next one, in the file 2, what I can try to do is that class sample 4 we are going to create. This one is a child of sample. This one is what? Child of sample. In this one, constructor okay, constructor. In this constructor, what you can try to identify, we are able to access what type of members. Notice, private member anyway accessible, not accessible. Protected accessible, because sample 4 is what? Child of sample. So we can access them. So we can access that B. B is a private protected member. Next, C, not accessible because it's internal, right? Internal means what? Within the same program only accessible, right? Not in another program, not in a different file. Within the same file, yes. In other file, not accessible. That word file may not be correct. Assembly is the correct technical word. Same assembly accessible, in other assembly not accessible. So next, protected internal accessible. That means D value we can print. What about E? E is a public. That's anyway accessible. No need of asking. Okay, fine. Next, sample 5 we are going to create. This is the other class. Other class at the other assembly. Okay. There, which of these are accessible there? Private not accessible. Protected and not accessible. Internal not accessible. Protected internal not accessible. Then which one is accessible? Only public. Only we can access which one? Public. Okay. Now, so we are able to create another class, some test class. In this static void main, in this I want to call all that classes, then only its constructor will be called. I want to create object for which class? Sample class. When we create object for the sample class, automatically its constructor will be called. Even I told that point in object lifecycle, whenever we have created object for the class, automatically it's a constructor will execute. So new sample means automatically this constructor part will execute. So you will get this output. Okay, let's create objects for remaining classes later. Let us stop this class at this moment. But how to compile? See, if you compile this first file into .exe, it is not possible to share its classes to exe file, other exe file. Exe to exe will not be shared. In case if you want to share the classes of one file to other file, this first file must be DLL file, dynamic link library file. Then only it is able to share the classes to other files. So file 1 cannot share the classes to other files. Cannot share. If you can make this as a DLL, then we can share its classes to exe file. But how to generate this DLL file? If you go csc file name.cs, what file we are getting? You are not getting DLL file. You will get exe file. In order to get the DLL file, what you have to say? We have to go csc file1.cs. We have to give one command. Target equal to library. By giving the option target, you are able to generate the file1.dll instead of file1.exe. If you mention this part only, you will get file1.exe file. We don't want that, because if it is exe file, it will not share its classes to other file. So that's why we have to add this /target:library. Same like this. To compile the file2, we should give file2.cs/reference equal to which file should be loaded. I want to load which file? File1.dll. So file1.dll should be the reference. While compilation, we have to follow like this. Just check it out. So csc file1.cs/target library. Okay, CDE does not exist, it is saying in the file 1, because here this CDE accessible but only through object. Without creating object it is not possible. So we have to create object, new sample. We can create object, through object only we can access them. Okay, fine. So new with object only it is possible to access that fields. But in the child class, no need of creating object. Even in the other assembly also, in the child class, no need of creating object. Remember it. In other classes, we must create object. In the child classes, we need not create object for the parent class. So here we must create object, then only it's possible. Okay, just compile this once again. Now it is compiled successfully. Next we have to compile file2.cs reference, which one? file1.dll. Sample is inaccessible due to its production level. See, sample is basically present in the first assembly, first program. Its default access modifier is what? See, I am not asking the field access modifier, I am asking the class access modifier. What the class access modifier? Internal. For the classes, default access modifier is internal. Internal class is not accessible in other files. The internal class present in one file, but it is not accessible in other file. That's why we must make this class as a public class. Then only it is accessible. When these also better, it must be public classes. Then only we get able to access these classes in other file, means in other assembly. Okay, so compile once again. file1.css/target library, then csv file2.cs reference file1.dll. Now check it, it's successfully compiled. Then can we execute that file1.dll file directly? Check it. File1.dll file generated. Can we execute this DLL file directly? No. We cannot execute the DLL file directly. We can execute only which one? exe file. That's why we have to give file2. It is not possible to give file1. We cannot execute the file1 directly. So we got that 10, 20, 30, 40, 50. So let me comment this, because the problem is when you create object for the child classes, automatically, sorry, not this. When you create object for the child classes, automatically parent class constructor will execute. Suppose you created object for sample2, unnecessarily, unexpectedly, it will execute the parent class constructor also. Then you may get confusion. To avoid the confusion, I am just commenting this. Okay, leave it. Now let's create object for the sample2. Sample2 objects only we are going to create. Again compile this. Same process repeat. csc file1.cs/target library. Ignore that warning, no problem. File2.cs reference file1.dll. Now execute the file2. Now which are all accessible? Check it. 20, 30, 40, 50. Except private, remaining only accessible, because we have created object for which class? No, sample2. We have created object for sample2 means only this part will execute. So we, as a result of that, B, C, D, E only we got. We don't get A, because A was a private member, right? Okay, fine. So this part is clear. Now let us see this output. In order to execute this part, for which class we have to create object? Sample3 class. So we have to create object for sample3 and compile this program. Same program repeats. File1.cs target library. Ignore that warning, no problem. Reference file1.dll. By reading that DLL file, after reading the DLL file only, file2.cs will be compiled. That is the meaning of reference. What is the meaning of reference? First it will read that DLL file, it will identify its classes, then on that knowledge only it will compile the file2.cs file. Okay, fine. So if we execute this file 2, we are getting 30, 40, 50. That is because of these three statements, that is C, D, E. We don't get A, B because A is a private and B is a protected, not accessible in this place. Okay, fine. Now let's create object for the sample4. Sample4. Again same process repeats. Then file 2. So we got 20, 40, 50. 30 we don't get, check it. That's because of this B, D, E and respectively. So that part is clear. Now let's run file and let's create object for which class? No, sample5. Sample5 only we are creating object. If you create object for sample5, what happens? its constructor will execute. So we got which one now? 50, just 50, because at this place only E is accessible, right? But see, the problem is, if you give the uncomment this one, what's the problem? I will explain. Listen. Just if you compile this again, unexpectedly that parent class constructor also will execute. We have created object for sample 5 means, okay, unexpectedly it will execute the constructor of that particular class also. We don't want that generally, so that's why, to avoid the confusion only, I have given just comments for the first class constructor. So let's see the output of all the classes together except the sample class itself. Sample 2, sample 3, sample 4, sample 5. These 4 outputs I want to demonstrate at a time. So then what to do? First, so child class at the same assembly. Next, other class at same assembly, child class at other assembly, other class at other assembly. Class names are sample 2, 3, 4, 5 respectively. \n I am giving just for going to next line. Okay, now check it. So all in one example here. So just check it. CSC. Just recompilation again. Ignore that warning. That warning will be clear when you just uncomment that constructor statements. So just ignore that warning, no problem. So file 2. See, we have 100% demonstration here. Child class at the same assembly, child class at the same assembly, other class at same assembly, child class at other assembly, other class at other assembly. Here what are accessible? Check it. 20 means what? B, right? B means what? Protected, right? So protected member, internal, protected internal, public. Here what are accessible? Other class at same assembly, internal, protected internal, public. Here which one accessible? Protected internal, public. Here only public. So we have completed the demonstration of access modifiers of the fields.